Okay, so welcome to Math 219. I'm Clark Bray, and I'm looking forward to working with you in one of my 3 sections that I'm teaching this spring 2023 semester. I'm teaching sections 1, 2, and 3 of Math 219. Okay, so I have some introductory comments and advice to talk about how the course is going to be organized and how I advise that you can best go about doing as well as you can in this course. And I think it's better to go through this here before we get into the math so that we don't waste valuable class time on this sort of, clerical, sort of, relatively simple stuff. Okay. All right. So first, a really quick comment. If you're thinking about a math major, please come talk to me. No big deal, but I think it'd be a good idea for me to talk to you about courses you've already taken, courses you're planning to take, and just make sure that you're on the right track. Okay. Alrighty, so as for the organization of the course, we're going to be mostly organized on Sakai this semester. You'll notice that there are 2 Sakai sites. There's one that is what I call the course Sakai site that has information that applies to all sections of the course, all the instructors, all of their different sections. And then we also are going to have what I'm going to call my Sakai site. And that's for information that applies only to my sections of the course. So we divide it up that way for various reasons. So you'll see that on Sakai. Here we are on Sakai, and you can see the 2 different sites. Math 219 SP23 is the course Sakai site, and then the one that has the section 01 inserted into the middle of the name. This is the one for my sections, and this is an unfortunate naming convention when you have multiple sections in the same Sakai site. The naming convention is on the basis of the first listed section, and unfortunately I cannot change this. So nevertheless, this, even though it only says 01, this applies to sections 1, 2, and 3, all of my sections. And again, this one here, all sections of the course. Okay, so I think it's very important that you read all of this information. You don't have to memorize it, but you want to make sure that you know where everything is, and you do want to make sure that you understand important things such as what is the grading policy for the course, and when is which homework due, and what day is the exam. There's a bunch of very important information, and you want to make sure you know where all of that is. Okay. There's also various links that are included, and I think it's a good idea to, familiarize yourself, make sure you know what's where, and maybe click around a little bit on those links. Okay. All right. Now, there's some specific things I want to comment on that are on the Sakai site. We're going to start with the content syllabus. I'm going to come back over here to we're on the course Sakai site, you'll notice. And, real quick, let me come over here to the syllabus. While we're here, I'll note that this is where we have all the instructors are listed here, and contact information and office hours. These places will get filled in very, very soon. Again, while I'm here, let me also point out that even though presumably, if you're listening to this recording, you're in one of my sections, you are nevertheless welcome to all of these office hours. So again, all students are invited to all office hours for Math 219. So I hope you'll make good use. Professor Stokels and Professor Silliman will be able to give you great help. In addition to, I hope I'll be able to give you great help as well. Okay. All right. A bunch of other information on the syllabus. I'm going to let y'all read most of this. And as previously suggested, let's now go over to the content syllabus. So this page on the Sakai site, roughly speaking, tells you what is in this course. So notice that there's some prerequisite material that's listed. I note the prerequisite trail. So the prerequisite for this course is linear algebra. The prerequisite for linear algebra is single variable calculus. The prerequisite for single variable calculus is high school algebra, geometry, and trigonometry, etc. So I'm going to assume that you are proficient with all of that stuff. Now, some of that is more important to the Math 219 material than other. So some specific topics that you want to make extra sure that you are super proficient with. So linear transformations, how those relate to matrices, what I'm going to call standard geometric examples, such as rotations and reflections. How does one write down the matrix representing, for example, a rotation in 3 space around the x-axis by a certain angle, for example? It'd be a good idea to make sure that you can do that. Okay, and if you have trouble, if you're not sure how to do that sort of thing, then that'd be a great thing to come and ask in office hours. In single variable calculus, derivatives and integrals, pretty much, but specifically, make sure you know the definitions of these things, right? And know how to do applications of them, and various techniques such as chain rule and integration by parts and things like that. You want to make sure that you're good with those kinds of things. All of that stuff, all of this prerequisite material is going to figure very heavy in Math 219. Okay. All right. Proceeding on down. Here is the material that we're actually going to be covering in the course, and you'll see that there is a column here showing which sections in the book we're going to be covering, then the names of those sections, titles of those sections. There is then a list of exercises for each section. So, in particular then, when we finish section 1.4 on the cross product, when that is assigned as part of a homework exercise, then these are the exercises that you're assigned to do. Okay, you don't have to do all the exercises in the section, just the ones that are listed here on the content syllabus. You'll notice that in some of these sections, we have some book exercises followed by AHP. AHP stands for Additional Homework Problems. These are exercises that I have felt the need to add because the book didn't have anything sufficiently comparable, and they were ideas that I think are important, and I wanted to make sure that they're represented. So this additional homework problems document you'll find in the resources section of this Sakai site, and you can just download it. It's a PDF. Okay. All right. So now, additional information that's on this content syllabus. I'll remind you, this is, here we are, Math 219 content syllabus. While I'm here, the textbook by Susan Colley. Excellent book. I like it a lot. So 2 extra columns. We have a column here called included material. So this is additional material that's part of the course that you are responsible for, but which is not covered in the book itself. The book has just a few little gaps, in my opinion, and so I've documented, additional things that I'm going to cover. So, for example, in section 2.5 on the chain rule, they really, in my opinion, should have some discussion of how to do second derivatives, and there's some tricky aspects of that. It's very important in physics and engineering, and I think it's well worth being discussed in this course. And again, oddly, not in the book. So that discussion you will get in my lectures. It's in my lecture notes as well. And again, part of the course, fair game for exams, not in the book. Okay. A few other topics where I have additional material as well. Okay, next column, excluded material. So this is stuff that is in the book, but that we're not going to include as part of this course. You're not responsible for it, and you can pretty much just ignore it. Take a glance for intellectual curiosity. Just quick little look-see. But you're not responsible for it. You shouldn't focus on it or spend time on it. The reason that I have to have this column is that as much as I really do like this textbook very much, it does. It's a higher cut through the material than the intended target of Math 219, and so. There's therefore certain things that we're just going to skip. So, for example, in section 1.7, when we're talking about coordinate systems, you can ignore the section called hyperspherical coordinates. Just don't worry about that at all. Okay. But notice there is a lot of excluded material. And so be sure to keep an eye on this as you're going through and studying the course. You don't want to spend a bunch of time getting bogged down on, proofs of certain theorems only to find out after the fact that that's excluded and you're not responsible for it and didn't really need to do that. Okay. All right. So that is the content syllabus. Going back now to my outline. And I'm going to skip down here to the section called course grades, because that also is on this same course Sakai site. And I'm going to just go a little bit further down here. Course grades. Very important topic, of course. Want to make sure that everybody understands how grades are going to be computed in this course. And roughly speaking, it's going to be by way of a weighted average. A weighted average is, it's a little mathematical construction for averaging numbers. Well, you consider some of them to count more than others. Details for that you can Google. It's an easy Google. And coincidentally, we are also going to be talking about weighted averages later in the course, but you shouldn't wait for that point. Go ahead and Google. Make sure you understand what a weighted average is. So all of your graded items, such as midterm exams and the final exam and homework and attendance, are all going to have designated weights. They will all be grades on the 4-point scale. So 4.0 is an A, 3.7 is an A minus, 3.3 is a B plus, etc. So on that scale, every graded item will have a number on that scale. We will then do a weighted average using these weights, and that will determine your weighted average for the course. That weighted average will then fall into one of these bins over here. So, for example, if your weighted average were to end up as 3.86, let's say, that falls into this bin, and that would be an A for the course. If you end up with a 3.52, that falls into this bin, and that would then give you an A minus for the course. Now notice we have inclusive on the lower side of the ranges and exclusive on the upper side. Said differently, if you end up with a 3.8 exactly, you do not round down to A minus. If you end up with a 3.8 exactly, you round up to A. Okay. All right. So I hope y'all will feel free to come and talk to me about this. If you have any questions about how grades are computed, and there's some more details we're going to talk about in a few minutes, but please don't hesitate to come talk to me if you're not clear on exactly how grades are going to work in the course. Okay. Now, moving along. Let's see here. Let me go ahead and talk about grades a little bit more. I'm going to move over now, though, to my sections Sakai site. Again, different site, my sections only. And you'll notice that there is another section called course grades. So here I include the specific additional details for just my section. So in particular, notice there's a paragraph here talking about how homework is going to be graded. And it's a formula. Y'all can read the formula. I will point out that I dropped the lowest homework score for each student. That's intended as a sort of a way to give a certain amount of flexibility to students. And then there's a discussion here about attendance. Attendance is part of the course grade. Very small part, but nevertheless a little bit. Every little bit counts. And this is how I'll compute attendance grades. So then down here we have all of the exact weights that we'll be using in my sections. So you'll notice each of the 3 midterms is worth 20% of the weight for the course. Per the course policy, final exam is 30%. And then here's my other, you may recall from the course Sakai site course grades section, I have 10% discretion on how to do other things, and so I have 7% for homework and 3% for attendance. Okay, so these are all of the weights that we'll be using, and again, weighted average fall into one of those bins, and that determines grades. So again, just to be clear, if you have any confusion about how grades work, just come talk to me. No problem. You can grab me after class. You can come to office hours. We'll pound it all out. Okay. Let's see. Also, I guess while I'm on the subject, let me talk about the exam curves. So this is where you will find the exam curves. They're not there yet. Of course, I haven't written the exam, so can't begin to curve them. But this is where you will identify what your exam scores, your raw scores, between 0 and 100. How would you convert your raw scores into grades on the 4-point scale? In other words, something between 0 and 4.3. 4.3 being an A+. So how does that conversion work? Well, it depends on the exam, and for every exam, we have a different curve. For exam 1, this column here on the left is the curve, and again, not filled out yet. But if you were to get let's say a 78 on exam 1, then what I will eventually put into this spot here will be your grade on the 4-point scale. Okay, so again, these will be filled out after the exams, so that I can account for how hard the exam ended up being in how these curves work. Obviously, if the exam is hard, I want to give a correspondingly, I want the curve to reflect that, so that students don't get disadvantaged by a hard exam. Okay, so let's see here. Going back then to our outline, let's now talk about the lecture schedule. So a lot of good information on the lecture schedule, exam dates, what I'm planning to do in class, what the homework assignments are, when those homework assignments are due. All of this is on the lecture schedule. This is part of just for my course. The other instructors have their own schedule for the course. You'll find mine, therefore, on my Sakai site. There it is, lecture schedule. Click on that, and here we are. This is how we're going to keep track of what we're doing as we go throughout the term. So, for example, first day of class coming up real soon. Let's see, what's that, day after tomorrow as of this recording. We have a class meeting, and my goal, we'll see if I make it or not, but my goal is to finish in my Chapter 1 notes through page 9. That's my goal. And I may or may not actually reach that goal. In the next columns over here, you'll see I'm going to be documenting as we go through how far did I actually get in Section 1 and in Section 2 and in Section 3. So those will help me keep track of where we are and that sort of thing. Okay. Note that holidays are indicated on the schedule. And spring break, the other holiday, exam dates. This is all fixed and documented on the schedule. Final exam, Tuesday, May 2nd, 7 to 10 p.m. as scheduled by the university. Okay, next, let's talk about homeworks. So in the homework assignment section over here, notice, for example, let me go down here to, let's see here. Well, I'll go ahead and do homework number 1. That's the most pressing one. Homework number 1. Okay. You'll see from how I have the rows grouped that this homework 1 spreads over these 4 class meetings, and it doesn't highlight very well. But the first 2 class meetings, that's 3 class meetings. There's no class meeting on the holiday, of course. So this is part of homework 1, this is part of homework 1, and this is part of homework 1. Okay, so on each of these days, so for example, on next Wednesday, January 18th, we will have finished certain sections from the book. We will have finished my discussion of those certain sections. Whatever we finish on that day, I'll come over here, and in that spot, I will fill in whichever sections we finished on that day. Homework 1 then is going to include all of the sections that we finish on all of the corresponding days. Okay. All right. For example, maybe on this first day I'll finish section 1.6. I actually am going to do section 1.6 first. I'll talk about that later. And then maybe section 1.1 and 1.2, and then maybe 1.3 and 1.4 down here, something like that. All of those sections would then be part of homework 1. Okay. When is homework 1 due? Well, here you go. Right there. Friday, January 20th. Homework is going to be submitted on Gradescope. There is discussion about Gradescope back on the Course Sakai site. Let me get back over there real quick. Bear with me. Come on, Internet. There we go. There's a section here called Exams and Homework. Again, you need to read all of this. In particular, here's the section about homeworks, and there's a discussion here about Gradescope. Okay. All right, so going back then to the section Sakai site. Homeworks are all going to be due at 11 p.m. It's one of the nice things about having a system like Gradescope is they don't have to be due at class time, which is arbitrary and inconvenient. So always due at 11 p.m. Eastern Time, Durham time. And so I think that should give you everything you need to understand how the homeworks are organized. I will point out, just to avoid possible confusions, note that the grouping of the homeworks does not fit perfectly with the weeks, right? So in particular, homework 1, the last day is Wednesday's material. And the idea there is that, obviously I can't cover material on Friday and then have the homework due on Friday. That's not reasonable. You should have 2 days. I think 2 days is nice to be able to get all that done. Okay. All right. Now you may be thinking to yourself, 2 days doesn't sound like a lot. We have 3 class meetings worth of material. And then after that last day, there's only 2 days to get it done before it's due on Friday, January 20th. And so, what's up with that? So my response to that is you shouldn't be waiting, right? So in particular, on this date, we're going to cover certain sections. You shouldn't wait until the following Wednesday to start working on those exercises. That's not a responsible approach to the course. Ideally, the sections that we finish on Wednesday, those assigned exercises that will be indicated here, on that Wednesday, you should start those exercises ideally that same day. And I understand you have different schedules and that might not be feasible, but certainly very soon after, surely by Thursday, you'd have a chance to at least start those exercises. So the hope then is that when this Wednesday rolls around, you should already be mostly done with all of the exercises from the first 2 dates that are included for that assignment. So this should be after this Wednesday. If you're on top of things and organized and up with it, you should only have 1 lecture day worth of exercises left to be done before it's due again on Friday, 2 days later. Okay. Alrighty, let's see here now. Last thing I'm going to talk about on the lecture schedule is the exams. Again, we've already noted that the exams are they're listed here. You'll see also that there is a color coding. The purpose of the color coding is to indicate what is fair game for that exam. So, for example, Friday, February 10th is the date of our first midterm exam. What's fair game for that is all of the material in this green section. So the green exam, the fair game material is the green sections, the sections of the book in the green cells. Okay, so in particular then, notice that what we do on Wednesday, February 8th, notice that's a yellow section. So that's not fair game. And my rationale there is, well, we don't really need to get that onto that first exam. It's not pressing that it be done so quickly. So I think it's a nice luxury that I'm going to go ahead and take advantage of to have the fair game material stop here. That gives you then 4 days on that material to prepare for the midterm on that Friday. Okay. All right, so you'll notice a similar thing here for the second exam. The last day of fair game material, again, is Monday, March 20th, as you see by the yellow. And so the material the material for Wednesday is not fair game. That material that we'll cover on Wednesday, March 22, that's in the blue section, that will be fair game for exam 3. Okay. Tragically, of course, there is no such luxury for the last exam. There is no subsequent midterm that I can push the material off to, and so there is just a 2-day turnaround on that material. Can't be helped. Okay. All right, and then here's my little color coding indicating what's fair game on the final. Namely, everything is fair game on the final. Exam 1, Exam 2, and Exam 3 material, all of it, all fair game for the final exam. Okay, real quick, I also want to talk about what I mean by fair game. So let's talk about Exam 2. It's in yellow. All of the yellow sections here are what the fair game material is. Here's the thing, though. That Exam 2 material is also going to make use of material from the earlier sections. So it's not that you don't have to know the earlier material. Of course you do. Of course you have to know the earlier material. That's prerequisite effectively to the later yellow material. The point to the term fair game is that all of the exam questions, the primary focus of the question will be yellow material. So on Exam 2, each question on Exam 2 will be aimed primarily at material in the yellow zone. Incidentally, you may have to do some green skills. Skills from the green zone from earlier. But it won't be the focus of the exam question. Okay. All right. That's the lecture schedule. And then moving on, recordings. So I always record, technology permitting, circumstances permitting. Every so often something breaks, something goes wrong, you never know. But my intention is to record all of my lectures. And then I have those recordings available on a YouTube channel. And you can get to that YouTube channel very easily. Again, from my Section Sakai site, you'll notice that there is a link right here. And you just click on that and it will take you to my playlists page for my YouTube channel. And on that playlists page, I don't yet have a playlist for this term because I haven't made any recordings yet for this term. But within the next couple of days, at the end of the day on Wednesday, I'll have recordings. We'll have that new playlist, and that's where you will find that playlist. Anyway, I hope that those recordings will be useful, and in particular, I hope you'll make heavy use of these recordings. And I'm going to talk about that in a little bit more detail in a few minutes. Okay. All righty. So that's a lot of the logistics. Now I want to focus a little bit on learning goals and learning strategy. Let's start with learning goals. This is a really important point. This is arguably the most important point that I'm going to make today in this recording. And this is in terms of what the course is fundamentally about. A lot of people have the wrong idea, what I think is the wrong idea about what math courses are about. A lot of people think that math courses are about answers. And I say it's not really true. It's not really what math courses are about. Math courses are about ideas. There are ideas, constructions and, machinery and definitions and theorems and things like this. It's the ideas that math is really about. And the answer at the bottom of the page is, that's, it's a nice thing to get that right as well, but it's just not the focus of the course. So ideas and reasoning, right? Deductive, mathematical, analytical reasoning is what the course is about. Now, it follows that if you have all the right ideas and valid reasoning, you will, yes, also get correct answers. But it doesn't go the other way around. If you have an answer, then I don't know what the reasoning was that got you there. I can suspect that maybe you understand the ideas, but I really don't know. And so, again, not what the course is about. So please don't just write down answers. Make sure to show your work, make sure to explain your reasoning, and make sure that you communicate in that showing of your work and in that reasoning that you explain. Make sure you demonstrate that you understand the ideas that are relevant to the question. And so, not so much answers and conclusions, but ideas and reasoning. Okay, so this is a really big point. Again, it's, this is inconsistent with the sort of fundamental philosophy of a lot of high school math classes, possibly some earlier math classes. Maybe you took somewhere else. Who knows? But I want to make sure everybody's clear on how this class is going to run and what this class is about. So you're going to notice this very quickly in the lectures. You're going to notice that the lectures are a lot about ideas and reasoning. And I think you will also notice when you get to the exam questions will not be, please regurgitate the following, data. Please, execute, a given algorithm, apply a certain, a given formula to, certain specifics in it, plug and chug. It's just not what we do, here. Okay. All right. Rather, on exams, points are going to be awarded not on the basis of whether you have the right answer at the bottom of the page. It's just not. It's mostly, is your reasoning valid? Is your reasoning complete? How clear is the thinking that you've communicated? And how clearly have you communicated in writing? How understandable is what you've written? How unambiguous is everything that you've done precise, and is all your reasoning, valid and everything documented? Okay. All right. So keep that in mind. I urge you to think through the same way when you work on homework assignments. Think of homework assignments as being practice for how you should be writing on exams. So show your work and explain your reasoning. Explaining reasoning is a skill. It needs to be developed, and you don't want to go in green on the exams and try to sort of just do it from out of nothing. Give yourself that practice doing it on all the homework assignments as well, and that will help you immensely as you do so on the exams. Okay. All right. So again, this is arguably the most important thing that we're talking about today. Okay, so strategic advice. This class has a tremendous amount of material in it. It's just mind-boggling almost how much material there is in this course that you're going to be learning. And in particular, there's just not enough class meeting time to cover all of it. I mean, I can cover it in a sense. But it is not a reasonable expectation that you'll walk into class a blank slate, and then you'll walk out 50 minutes later knowing everything that you need to understand about that material. That's just not how it works. The material there's too much, it's too challenging, it doesn't work like that. So we have a strategy then for how you can learn all this material, but it involves a lot of work outside of class. So in particular, you should expect that much of what you will learn in this class will happen outside of class. So now here's my advice for what I think is a good sort of strategy to have, rough structure of how you're going to learn. First, before you come to class, go ahead and read through what we're going to be covering in class. Now, you should not expect that you would understand everything. Of course not. Right? If you could understand everything without coming to class, then we wouldn't have classes. But you can, presumably, hopefully, understand sort of the foundations of what we're going to be doing, the starting point, on what previously covered ideas are we sort of taking off. And then, you want to flip through and try to have a rough idea of what's going to happen with the rest of the material. And again, you're not aiming for perfect understanding here. That's not realistic. But it's tremendously valuable to already, to come into class already kind of having a rough idea of what's about to happen. It's tremendously helpful in keeping track of what's going on in the lecture and being able to focus on deeper points. Okay, next. Come to class. Obviously, you have to come to class to get these benefits. But in those lectures, keep in mind, I'm not going to be doing every single little thing. I'm going to have to make tough choices about what are the most important ideas for me to include in the lectures. And some of that will be the ideas that are most critical. Some of it will be the ideas that are most challenging. Some of it will be ideas that are the most difficult to get out of a written, reading form and much easier to get in a, visual, verbal explained format. So again, these are tough choices, and I do my best to cover the most important ideas. Important in the sense of the learning process. So that said, I'm going to be doing a lot. I'm going to be throwing a lot of ideas at you, and hopefully you will understand some of it. I assume you will understand some of it, but the surprise here, you will probably not understand everything that happens in lecture. So this is to be expected. The ideas just come too fast. But don't forget, these lectures are being recorded, and you have the book, and you have the notes. And so then after class, after you've understood, hopefully, some, at least some, hopefully most of what we did in class, after class, you have various resources to hit to fill in those gaps. So you can reread the section of the book, or reread those pages of the lecture notes, whatever I talked about in class that day, and the recordings. Go back to parts of the recordings where you got confused and listen to that part of the recording again. So now, specifically to that, how do you go back to those portions of the recording? This is a fantastic idea that I got from a student several years back. I think this is a tremendous strategy. And the idea is, in your copy of the course lecture notes, which you'll download from my Sakai site in the resources section, annotate your notes with timestamps indicating what the time was. Now you'll notice down here in the I can't circle it because it's not on the PDF annotator. But you see my clock is down there, and you can see what time it is. Well, on the recordings, you will be able to see. Why is that not going away? Ooh, I don't know how this works. There we go. You'll be able to see what time it was that I covered certain material. And so when you find yourself confused in class, jot down what the time is. And then when you fire up that recording at a later date, or possibly later that same day, to listen to it again, you'll know exactly where to click forward to find that discussion. So I think this is a great idea. And just as a for example, here's a copy of my lecture notes. Again, you'll get a copy of these on in the resources section of the Sakai site. Hopefully a lot of this will make sense, and we're cruising along. And then we get to this example in which I claim that suitably interpreted this function, which is computed from a determinant, that this function is a linear transformation. And that may seem like a weird statement to you first time you see it. And if so, fine. No problem. What you'll do then, when you find that unsettling, uncomfortable, you look down here and you see, oh, that happened at 2:57. Okay, so then you just jot 2:57. Just like that. And that's your note. And then later, when you come back, you'll know that when in this recording, you'll just fast forward to where the clock says 2:57 and tells you exactly where to go. All right. So anyway, I'm a big fan. I think this is a wonderfully simple but powerful idea to allow you to go back and study the lecture recordings later. Okay. All right. So 3-step strategy again for how to get the most that you possibly can out of lecture. So prepare before class, work with the notes during class, and then hit it all again after class. 3-step process. Okay, so there's also supplemental materials that I think can be really useful. So first I'm going to note, my old exam questions and solutions. I'm going to go back to the Sakai site for this. And in particular, this is the course Sakai site where you will find it. And if you go to the section called Advice and Resources, here we are, Advice and Resources. I want you to, again, reminder, you should read all of this. I'm not going to read through all of it myself, but make sure to read all of this. And down here, number 7, past exams. So what you'll find here, there's actually 3 collections of old exams here. The first is my past Math 219 exams. And the thing is, I've only been teaching Math 219 for about a year. In fact, it's only existed for a little over a year. So I don't have very many old Math 219 exams, but nevertheless, that's something. Okay, next, you'll find that there's some old Math 212 midterm exams. Now, you may be thinking, yeah, but that's a different course. How could a Math 212 exam be useful for a Math 219 student? And the thing is, 212 and 219 are extremely similar. They're not identical, but they're extremely similar. The main difference between these two courses is that 212 does not require linear algebra. 219 does require linear algebra. So in 219, I can present things from a more linear algebra point of view. That's very valuable as it turns out. You'll see how that manifests itself as we go through the course. But all of the same subject, all the same topics are covered in Math 212, just, slightly different take. So if you click on my old Math 212 exams, you'll notice this is a very large set. I've been teaching Math 212 since, let's see here, it looks like 2004, right? That goes pretty far back. And this is every exam and solutions from all of those times that I've taught the course. Okay, third folder here, my summer offerings of Math 212. Now, the main difference here, and the reason why, and again, notice this is a very large collection, another large collection. The reason I have a separate folder here for the summer ones is that in the summers, I used a different textbook. In fact, I used my own textbook. And one of the big differences, one of the things that I deliberately did in the book, is I included a short section on linear algebra, and so that I could use linear algebra in those discussions. So, in fact, then these old summer Math 212 exams, because they take that linear algebra point of view, at least to some extent, might actually be closer to Math 219 than the semester midterm exams. But they're all useful. They're all a little bit different. And of course, my 219 exams themselves are also all a little bit different. So all of this stuff is good practice material, and I hope you'll make a lot of use of it. Okay. All right. Old recordings. Other supplemental material. Every class that I've taught since, I think, 2015, maybe a little bit earlier, I've forgotten. Anyway, for quite a few years, I've been video recording all of my class lectures. So now, how does this affect you? Well, if you want to get a slightly different take on, some topic from Math 219, you can look at how I taught it last spring. Or you can look at how I taught it in Math 212 5 years ago. And each time I teach a topic, it's maybe a little bit different. And you may find that those little differences, just slightly different takes, might help something make more sense for you. And so that's another nice resource, and I hope you'll take advantage of that as well. Okay. All right, another suggestion here. I think this is another good one. Maintain a list of questions. So it's easy to lose track of what it is that you don't understand. All right. So if as you go through the material, after you're doing your after class, following up, filling in gaps, you very likely may find that there's certain topics you just can't get. You just don't understand. This is all perfectly reasonable. Nothing wrong with that. So when you find some point that you just can't make sense out of, add it to your list of questions. And then this running list of questions, you take that with you when you go to the help room, or when you come to my office hours, or when you go to one of the other instructors' office hours, or what have you, or when you talk to your friends who are also enrolled in the class. Just have this list of questions, and then you won't lose track of, you won't forget in some sense to go back and clarify a certain point. And then, of course, when you get it clarified, cross it out. And so your list will get crossed out, and you'll be adding more items at the bottom and crossing out items at the top, and you can just keep track of what else you need to do. Okay, so additional course resources. I hope you'll take advantage of all this stuff. Office hours, again, don't forget you're invited to all the instructors' office hours. All of those hours will be posted eventually. Should be before classes start. The help room, I think, is a great resource. It is open, I believe it's 2 nights a week. I want to say Sunday and Thursday, I think. Anyway, you know what? Let's just find out. Easy to do. Right here on the advice and resources page, come down to help room. We'll just click right there on that link. And here is the help room page, and you see multivariable calculus and linear algebra. This is multivariable calculus. Of course, we click on here, and there's the schedule for spring 2023. And you see we have multivariable support, including Math 219. There's 219 on Sunday and on Thursday. So it looks like I was right. Okay. All right. So all of the staffers for the help room are they're either undergraduates or graduate students. They're all highly proficient in the subject that they are teaching. Many are math majors, advanced math majors. All of them have done well in this or comparable courses and are very qualified to give you good help. So great resource, and again, I hope you'll take advantage. Okay. All right, going back to the outline. So don't forget about the Academic Resource Center. They have some really good options as well. And again, you'll find some links to that on the Sakai site here. So ARC Resources, notice. Whoops. ARC Resources. So they have various different resources. It changes every semester. In general, you can just go to their website and click around, see what they have. In particular, the SAGE program is really nice. It's kind of a parallel, supplemental, I don't want to call it a course. It's kind of like a study group in a way, but it's guided with a mentor who will be leading the discussion and taking you through maybe a different point of view on some of the ideas. I'm also, of course, don't forget about peer tutoring. That's another free opportunity for help. But I'm also a really big fan of this program called Study Connect. If you don't have a study group to work with, if you feel like you're kind of all alone in the course, just sign up for Study Connect, and they will find other students taking the same course who are also looking for study partners, and then they will hook y'all up. So it's a fantastic idea. I'm a big believer in group work. In fact, I think that's the next item here. Yeah, next item I have on my list. Have a study group to work with. It's a great way to learn. I learned a tremendous amount of material myself from study groups when I was an undergraduate long ago. And it's really good stuff. Now, properly utilized, of course. You want to make sure that your study group doesn't turn into basically a hang. As much fun as that can be, you want to keep the topic on math and not you don't want it to be a distraction, right? My favorite technique when I was an undergrad was roughly speaking to try to create dialogue. So, for example, you can just say, all right, you're sitting there with your group, and you've got let's say there's a total of 3 or 4 of you there together. Just take the floor for yourself and say, okay, proposition. All multivariable integrals are linear transformations on a certain vector space. Just throw it out there and then ask people to respond. Do you think that's right, or do you think that's not right? And that'll lead to, well, what do you mean? In what sense is an integral a linear transformation? And what are the parameters defining how you're thinking of an integral as a function? And some people will say, "Oh yeah, I believe that is true," and others will say, "No, it's not. Come on, that couldn't possibly be true." Really? Why would that be true? And then you can come back with your reasoning, and they can argue with you with their reasoning, and now you've got a dialogue going. You've got some back and forth, and you're mixing it up. And this is a wonderful way to either uncover something that you misunderstood by someone correcting you on it, or if you were right, then you get practice in communicating what you understand. And communicating what you understand, again, very hard to do. And keep in mind, being able to communicate, being able to explain your reasoning is a large part of what you're going to be tested on the exams. So if you're right, then this is an opportunity for a winning this is a useful way to spend time. And if you're wrong, well, then again, it's a useful way to spend time. It's just, it's very win-win. So, create dialogue in, one way or another. There's different variations on this. You don't have to, submit a hot take to your group and then, discuss, afterwards. Here's another thing you could do. You could prepare let's say a 3-minute mini lecture on topic that you're finding that maybe you're a little confused about or something, and spend 3 minutes talking about what you think you understand, and then same thing after your 3 minutes. Then your group would then critique and say, well, you were right about this, but I think you may have been wrong about this other thing. And then, by the way, you totally left out all this other stuff that is also important. And then, again, conversation ensues. Very useful. Okay. All right. So, I think we're mostly done here. I've already hit this last point previously. I'll say it again real quick, but don't forget to use your homework as practice for the exam. Again, showing work and explaining reasoning is easier said than done. The art of being able to take ideas that you understand in the abstract and put them into a combination of words and equations and symbols is a skill. And if you do it on the homework, you will get better at it, and that will make you do better on the exams. You'll have better clarity of communication on the exams. So I think another really good idea. Okay. All right. So that's everything I have. And I look forward to working with y'all in this course. This is a wonderful course. A lot of work, a lot to do, a lot of material. It's very challenging. But I think it's also very rewarding. It's very beautiful material, and I look forward to working with you and talking about it. Okay, see y'all in class.